This time we have hydrogen gas, and we are given volume, temperature, and pressure. And those conditions are changing. It's asking us for the new volume, given changes in temperature and pressure. So let's start with the ideal gas law. It's pressure times volume is equal to the number of moles times the universal gas constant times temperature. Now all these variables except for the number of moles is changing, so we're going to move all the variables to the left side and all the constants to the right. We can do that by dividing through by T, or temperature. So we get PV over T is equal to the number of moles and the gas constant R, which aren't changing in this problem. So if we have all the constants to one side, we can say that any combination of P1, V1, and over T1 is going to equal any combination of P2, V2 over T2 of this system of gas. All right, because it's all going to equal this constant. By the way, this is known as the combined gas law. And before we use it, we have to change all the Celsiuses to Kelvin by adding 273.15, and that's going to give us 296.15 Kelvin. And then let's do the same thing for 40. 40 plus 273.15 is 313.15 Kelvin. All right, we need to use Kelvin in all our gas laws. Now, let's go back down here and take the combined gas law and rearrange it to solve for what volume. All right, so let's solve for V2. V2 is going to equal P1 V1 T2 over T1 P2. Just do a little algebra. All right, time to plug and play. All right, P1, initial pressure is 9.956 atmospheres. V1, initial volume is 12.4 liters. And the final temperature is 313.15 Kelvin. And that's all going to go over. The initial temperature is 296.15 Kelvin times the final pressure is 0.956. Wait a minute, that's the initial pressure. What? Final pressure didn't even change. All right, well, we're already gotten this far, so a little trickery going on in this problem. All right, so this stuff just canceled out, so it would have just been Charles's law. Okay. Just make sure everything else is changing. Yep, we could have just used Charles's law. Let's punch these numbers in our calculator. 13.1. That's all these units. Liters. 13.1 liters.